Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this is part 2, analysis of frame. Analysis of frame, one inclined member, one inclined column. So this is Sidesway frame. So in my previous video, I have discussed about first part of analysis where we analyze the properly restrained frame. Means that we calculate FEM due to external loading only. Okay, now we will move to part B. So part B is Sidesway frame. Sidesway frame means that we will analyze, we will calculate FEM due to Sidesway or due to delta only. So this is part 2 of analysis. Okay, the diagram in shown right now is actually the original diagram. So when we apply when we want to calculate or analyze internal moment or member end moment using moment distribution method, we actually apply the principle of superposition. So the idea of using the principle of superposition is because we have to separate between two type of FEM. We have FEM due to external loading, and we also have FEM due to delta. Okay, now we focus on the Sidesway frame. Sidesway frame. This is the FEM. The FEM due to delta, and FEM due to delta for the second part of analysis, it is actually based on assumption. FEM, because FEM due to delta in Sidesway frame, the delta is unknown and remain unknown. Okay, the delta is unknown and remain unknown. So we will actually analyze one frame which is proportional with original Sidesway frame. Okay, from the principle of superposition, when we want to remove delta, we will change this frame to properly restrained frame. Properly restrained frame means we put pin so that we will get R. Okay, we will get R. So when the frame has a restraining force, okay, so the frame will not move to the side Sidesway, to the right or to the left. Okay, so it is called as properly restrained. So so this is diagram B. This is diagram B. Okay, and this is actually table number 1. And to fulfill the principle of superposition, so this one we have to plus with another frame which will neutralize the R. Okay, so if in diagram B, this another one is C. If in diagram B, R is in negative direction, left direction, so we will have another frame in R, which R is acting in right direction, so we will get back when negative R plus positive R, we will get back 0 at C, because in original frame at C there is no R. Because C can move to right direction, so that is why we have to neutralize the R. So we have negative R plus R. Okay, so original diagram is A. Okay, and when we want to analyze part 2, when we want to analyze Sidesway frame only, we actually analyzing diagram D. we actually analyzing diagram D. Okay, again. Okay, we actually analyzing diagram D. Okay, diagram D, same like C, same like C, but this time it is subjected to R prime. So this is diagram D, this is table 2. This is second part of analysis. This is table 2. So table 2 will be based on this diagram. This is a frame subjected to Sidesway, subjected to delta only. Subjected to delta only. So so this is actually the principle of superposition. So we actually want to calculate the moment, the total moment or final end moment in diagram A. Diagram A has a combination of FEM due to external loading, uh, FEM due to external loading, and another one uh, is due to delta. Okay, so we want to calculate final end moment, MF, final end moment, and the end moment that we get from table 1, we label as M naught, M naught. So look from the principle of superposition, so this we get M. Okay, the end moment, the end moment or internal moment due to R, we label as M. And end moment due to R prime, we label as M prime. We label as M prime. So for the equation based on the principle of superposition, MF is equal to M naught plus M. M naught we get the value from table 1, but M we do not know the value. But we have M prime from table 2. M prime from table 2. So by using interpolation, we compare these two diagrams. When we compare these two diagrams, we actually can produce relationship. Okay, a relationship. So we will get M and R. We get from C, and we also have M prime and R prime. M prime per R prime. Okay, so M prime we get from table 2. R prime we can calculate the value from shear equation. R prime we get is the shear equation from table 1. So here the M is the unknown. So by rearrange this, so we will get M, which is equal to R divided by R prime. Okay, we group R together, and R divided by R prime is actually equivalent to correction factor. We call this as correction factor. So we have to start with M prime. So M is R divided by R prime, R divided by R prime times M prime. And R divided by R prime is called as correction factor. Correction factor. So what we should do now is we have to substitute. So this is equal to M naught plus M is R divided by R prime over, not over, times M prime. So this is the equation to calculate the final end moment. We derive from the principle of superposition. So in summary, this is from table number 1. This is from table number 2, the value. So R we get from shear equation under part 1, table number 1, and R prime is we get from shear equation under part 2 from table number 2. Okay, now we are now moving to part 2 of analysis. So this is actually the final step where we will use this to calculate final end moment. Okay, anyway, we will go back to Sidesway frame analysis. So this is part 2. Okay, for part 2, For part 2 is Sidesway frame analysis. Sidesway frame. So for Sidesway frame, we will base on this frame subjected to R prime. Subjected to R prime. Okay, there is no external loading. Okay, so we will assume FEM for member AB, and we will use the value that we assume to calculate FEM for BC and CD using ratio. Okay. Okay, since the frame is tend to move to right direction, so we get shear for AB 90 degree is like this. Okay, and 90 degree for CD is like this. And beam we just need to join this position and this position. So this is the new beam position. So from this the delta the delta for AB we label as delta 1 naught. Okay, is this point, this one, this position. This is the delta. This is delta 1 prime. Okay, and then we get the delta for member CD as delta 3, this one. So delta 3. Okay, this is delta 3, and we combine to produce one triangular, and this is vertical. So this is delta 2 prime, and delta 2 prime is actually belong to beam. So in summary, so we have this triangular. This is 90 degree. So we have to find where is this triangular inside the diagram. And from this we have this as 3. So this one is also equivalent to this, and then the vertical displacement is like this. So it actually show to us that this triangular is located this. Okay, so that is the position in the diagram. So if the angle is given, if it is not given, we have to find the angle. So we check back the angle, is it given? Okay, the angle is not given. But we can calculate the angle. So from the length for member AB and the vertical distance, so we get this is 4 and 3, 2.65. Okay. Okay, looking at the original like this. Okay, 90 degree. So this is the triangular. Okay, so we have to have the angle which we get from this this is the length is 3, 4 and 3. This is 4 meter, and given also the vertical height, okay, is 3, 4 and 3. Okay, so this one is 3. Okay, 3. This is 3. So from this 4 and 3, actually we can calculate the angle. So we want to have this angle. So from this we will use sine sine theta. We get 3/4. 3/4. So theta is equal to we get 48.59, 48.6 degree. 48.6 degree means that this is the theta is 48.6, means that this one is also 48.6, and this 48.6 in the purple triangular will be equal, this one will be equal to 48.6. So this one is 48.6. Okay, this is 48.6. So this is the most important. This is the most important. We know that delta 1, this is perpendicular to member number 1. Delta 2 is vertical because beam is horizontal, and delta 3 is horizontal because column CD is vertical. So we combine all this, we get one triangular. So we will use delta 1 for member AB, we use delta 2 for member BC, and we use delta 3 for member CD when we calculate the FEM. So in order to calculate the FEM, okay, for the formula for the FEM, AB and BA, okay, the formula is 6. Check whether EI is constant or not constant. So 1 to 1, 1 to 1. Okay, it is 6 EI, 6 EI delta 1 prime over L is 4 squared. 4 squared. So this one is equal to 6 divided by 4 squared. 0.375. This is in terms of EI delta 1 prime. Okay, next. The formula to calculate FEM for member BC. FEM BC is which is equal to FEM CB is equal to 6 times 2 EI. Okay, for member BC, we use delta 2. So this is delta 2 prime over L is 6 meter, 6 square. So this one we get 6 times 2. 6 times 2 divided by 6 square. 6 square. It is 0.333 EI delta 2 prime. And we have to change this delta 2, change this in terms of delta 1 prime. In terms of delta 1 prime. So we need to write the relationship between delta 2 and delta 1. Okay, we use this triangular. Okay, between delta 1 and delta 2, between delta 1 and delta 2, from the diagram, we will use cos. We will use cos. So it is cos 48.6 equal to delta 2 prime over delta 1 prime. So in terms of delta 1 prime, delta 2 prime is equal to cos 48.6. We get 0.661 delta 1. Means that we have to substitute cos 48.6, which is equal to 0.661. We times with 0.333. So this one is 0.22 EI delta 1 prime. So now we have considered cos 48.6 into delta 2 prime. So we get FEM for member BC in terms of EI delta 1 prime is 0.22. Okay, formula to calculate FEM for CD equal to FEM for DC, okay, it is 6 EI delta 3. For member CD is delta 3 divided by L is 7.5. L is 7.5 square. So we solve this in terms of delta 3 first. It is 6 divided by 7.5 square. We get 0.1067 EI delta 3 prime. Now we have to change delta 3 prime in terms of delta 1 prime. So between delta 1 and delta 3, we use sign. So it is sine 48.6. Sine 48.6. So we get from this sine 48.6 is delta 3 prime divided by delta 1 prime. So to get in terms of delta 1 prime, so it is sine 48.6 delta 1. And sine 48.6 equal to 0.75. So 0.75 we times with 0.1067. Okay, so here we get 0.08 EI delta 1 prime. So these are the three value, we calculate based on the formula. So this is FEM in terms of EI delta 1 prime. So once we have the same EI delta 1 prime for all FEM AB, FEM BC, and FEM CD, then we can find the ratio, and then we can calculate the FEM based on the assumption. The first assumption that we made based on the behavior is if frame is tend to move to right direction, FEM for member AB is negative 100. So we have table here. So we have EI delta 1 prime and FEM here. So we have EI delta 1 prime for AB. For AB, we get 0.375 EI delta 1 prime. It is 0.375. Okay, for member BC, it is 0.22 EI delta 1 prime, 0.22, and then for member CD, it is 0.08. It is 0.08. So here is 0.08. Okay, assumption. We have to assume that FEM moving towards right direction for member AB is negative 100. Negative means the frame moving towards right direction. Okay, and for BC, the value, it should be positive because of the behavior, and for CD, the FEM will be negative, also due to behavior. So how to determine this negative? We get from the behavior. Okay, so the frame is like this. Okay, the frame is like this. So 90 degree for the Sidesway. We get for AB, we get this triangular. Okay, and for CD, we get another triangular like this. Okay, and then for beam, we just need to join this dot and this dot. Okay, so for A, B, new position is this. Okay, so in order to move back to its original position, so we have to apply. So we have this new position. New position is the purple line. Okay, the purple line. So this purple line or new position, we apply so that we get FEM to push back the column to its original position. So original is the blue line. The new position is the purple line. So moment, fixed end moment will push, okay, in this direction. Okay, push A and B. Okay, so that the purple line will move back to its original position. So this one is A and B. So this and this both are negative because of the behavior. It is counterclockwise and counterclockwise is negative. So that is why the FEM for AB is negative. Okay, same goes to CD. CD after Sidesway, we get like this. Okay, and CD, this is C, this is D. Okay, the new position of the column is this. The new position. And the fixed end moment will push this as well as this, so that the column will straight again, will move to vertical direction again. Okay, so the moment here and here, okay, acting counterclockwise. AB, the fixed end moment acting counterclockwise. CD, the fixed end moment acting counterclockwise. So that is why between AB and CD, we can find in the table that that negative. Both are negative because of the counterclockwise direction for the FEM. However, for beam is positive. FEM for beam is positive. How we get this? Okay, always remember that beam is a horizontal member. Okay, just pick this shape. Okay, so this is the new after Sidesway. The new beam position after Sidesway. So fixed end moment, because the original is horizontal. Original is horizontal, so this is B and C. So we have to apply moment to push this point as well as this to go back to horizontal position. So the moment that we apply is clockwise. This is clockwise. So that is why in the table for BC, it must be positive. And please remember, column both have same sign between AB and CD. And for beam, BC, it is opposite direction. So we interpolate to get the FEM for BC and CD. Okay, to calculate what is the value which is calculated based on 0.22. Proportional with 0.22, it is 0.22 divided by 0.375 times 100, and the value is 58.667. It is positive 58.67. And For CD, it is 0.08. 0.08, it is 0.08 divided by 0.375. 0.375 we times by 100. Okay, so we get 21.333. Okay, so this is actually the FEM that we will use in the table. In the table.
Ibu, dekat mengajar esok, mereka kata orang tua pun boleh pergi lah. Nampak ada orang tua.
Okay, so this is the value in the table. So we again okay, have the table number 2. So this is AB, BA, BC, CB, and CDDC. So we will use FEM here for the, of course we start with distribution factor, and FEM is negative 100, negative 100, and BCCB we use 58.67 positive. It is 58.67 positive, 58.67, and negative 21. So here we use negative 21.333 and negative 21.333. Okay, so these are the FEM value due to Sidesway. Okay, for one inclined column, we will analyze like this. Okay, so I will stop now because for the remaining analysis, okay, to calculate the end moment, and then we will calculate the shear equation. So we will continue in the next video. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Ibu, orang tua pun boleh main lah tengok mengaji.
Ya.
Dia kata.
Aisyah kerja sekolah ada tak?
Apa?
Kerja sekolah ada tak?
Kerja. Ada kan, tadi kan cikgu suruh Jawi dan Arab. Jawi dan Arab. Ibu, kan tadi cikgu bagi tuan